call upon Professor Majaliwa to start the training. Professor Majaliwa, over to you.
Yeah, thank you, Jolene, for those introductory words. A good morning, good afternoon to everyone. So as Jolene said, this is our second day. And for this second day, we wanted to do a short recap on what we discussed yesterday. And then we will start with the module 2 and module 3. Prof. Karume will actually do the recap. Prof. Karume, the floor is yours.
Thank you, Professor Majaliwa. We started yesterday by a rationale, why a course on clean energy options for sustainable agricultural productivity. And we said energy is critical to almost every aspect of the agricultural value chain. The food sector consumes 30% of the total energy supply and contributes to almost 20% on global emissions. Given that there is need to use clean energy in order to power agricultural value chain activity, which will enhance productivity on one hand and to fit the growing population. By doing that, we are going to reduce the amount of greenhouse gases emitted in the atmosphere, and at the end of the day, contribute to climate change reduction. But the problem, as agriculture is done in rural areas, these people, they are not aware of this renewable energy. That's why we sought to do this course for undergraduate students as well as workers, extension workers who actively work or support farmers with information on this renewable energy. So the goal is to impact microeconomics of rural communities through promotion of cost-effective clean energy options. And we had three learning outcomes. And Prof. Majaliwa talked largely about the outcome. And this can be summarized in designing, constructing, and operation of empowering system on farm to empower farmers. So coming to the course content, we said that the course had 5 modules. Module 1 is on power system structures, which is going to cover the primary energy sources and processing system. And these primary energy sources are mainly hydropower, wind energy, solar, photovoltaic, biomass, as well as geothermal. And Majaliwa quickly talk about competencies to be acquired for each module and the mode of delivery. I don't have to come back to that. So after that, we have seen that the second module of the course is going to cover clean energy option for agriculture value chain. And these value chains are going to cover input, production, local transportation, storage, as well as handling, value addition, and marketing. And that one will take us to module 3, which is going to focus mainly on conversion devices and trying to cover direct to alternating electricity power and alternating power to direct current. So we'll cover the first module will be about design to maintenance of on-farm clean energy system, which again are about hydro, solar, wind, biomass, and geothermal. So for this part of the course, we are going to see the design of these selected power generation systems, and we are going to see how we can construct them, and with a focus on biogas, because biogas is not a clean energy, but the other 5 energies are clean. We are going to see the storage and the maintenance of a given selected clean energy system on agriculture farm. And finally, the course will have the last module, module 5, which will talk about energy value chain economics. And 3 points mainly will be covered, or let's say 2 points. One on cost and pricing scheme, and the other one on comparison between existing options. So Professor Majaliwa started by power system structures by showing that the world existing electricity system was designed mainly for conventional centralized power generation. And at that time, large plants were set to generate energy, the bulk of the energy, using fossil fuel, which had a big consequence on the climate. So there was now a need to move from a centralized system to a more, let's say, decentralized system, which can be done using renewable source of energy. And this has the advantage of being decentralized type of power generation, and at the same time can increase reliance on a big number of energy instead of to be reliable on fossil fuel. And after that, after showing that when you today you treat energy issue, you should not only consider the issue of price, but you have also to consider environmental impact and reliability, as well as sustainability. And this is what gives more chances to renewable energy. So after that, Professor Majaliwa talked about primary energy and secondary energy. Primary energy, which was defined as a energy found in nature that has not yet been subjected to any human engineering. And this energy can be either renewable or non-renewable. And when you engineer the primary energy, you get the secondary energy, which is mainly is a carrier of electricity, of energy, such as electricity. Okay, that took us to hydropower as the first type of renewable energy. So on those different renewable energies, we were answering two main questions. The first question is what is about that energy and how does it work? So what is hydropower energy? Hydropower energy is energy obtained from falling water, which is falling at a certain height. And this is able to produce energy. So after talking about hydropower system, which can be classified based on either size, on operational method, on storage capabilities, and we come out with types of energy. The first one was, let's say, hydropower with which are based on a reservoir, and he had a number of these hydropower systems. He talked about advantages, which are mainly method powered generation system. Advantage, it can be reliable. Another advantage can be multi-purpose, because as we have a reservoir, it can be used for irrigation, it can be used for food, for flood control, and for water supply. The main disadvantage of that hydropower reservoir base is mainly high construction cost and environmental and social impact. It took us to the second type of hydropower plant, which is runoff river hydropower. Runoff river hydropower, which mainly can have as consequences, advantages, lower environmental impact. The second disadvantage, cost effective for small scale generation, and two main disadvantage, which can be summarized in power output, which depends on seasonal river flow and limited storage for energy regulation. After that, we had the pumped storage hydropower system, which is mainly constituted with two reservoirs, and one is filled by the second one using as a type of energy which can power a pump. It can be either wind energy or solar energy, which can pump water to the main reservoir. The advantages of this type is are mainly to provide energy storage and grid stability. It can be also to balance renewable energy such as soil and wind. And as disadvantages, we can require two reservoirs and significant infrastructure to be built. And we have the last one, high input cost. And from that one, we had the micro and small hydropower, which are used mainly in rural areas and can be able to give one from 1 kilowatt to 10 megawatt, which have as advantages local, or they are local for off-grid rural electrification. They are well indicated and low environmental impact because they are very small. And the disadvantages, we can retain limited energy output and seasonal water flow variation as they affect their performance. After that, we go to in-stream hydropower system, which are using kinetic energy systems and having advantage of no need for dams or major infrastructure and no minimal disposition to ecosystems. Disadvantages of this system is they are not suitable for a certain location. And another one, they are made for just limited energy capacity or capability. And the last one is about offshore and tidal hydropower, which also have as advantages renewable and predictable energy sources. They have high energy density in tidal regions. And as disadvantages, we have they are expensive and the technology is quite complex. And finally, they are limited to coastal areas. So after doing all that, the advantages or the disadvantages of these renewable energies were summarized in a table which takes into account all those characteristics. So after doing that, we covered the challenges of which hinder hydropower development. And among those challenges, we pointed out the high capital investment costs, the environmental and social concerns, the problem of climate change, which can impact them, the infrastructure gaps, mainly in our continent in Africa, and finally, the political and institutional barriers. Those are elements hindering the development of hydropower. So in Africa, hydropower has a big potential to be used and be able to develop a big amount of energy. So let's say currently in Africa, 330 gigawatts are produced for with hydropower, and it covers only 11% of the whole potential. And we have them in Central Africa, in East Africa, in West Africa, as well as in southern part of Africa. And we pointed out some sites where some rivers where it's possible to use hydropower for electricity generation. And this took us to the equation to allow us to estimate the hydropower energy, which is mainly power times time. And power can be estimated by taking efficiency times water density times the gravitational acceleration times let's say the flow and the height. And we emphasize that it's possible to measure the flow using very simple method, such as the bucket method and the floating method. And we can also simply measure the height on a site using just a stopwatch and the equation given by a gravity movement. when we know the time, we can determine simply the height. After that, we shifted to wind energy. What is wind energy? Wind energy and how does it work? Wind energy is energy produced by wind moving and acting on a number of blades. And we said we can have either even blades or uneven blades. And when you have uneven blades, which are more used for stability reason. When you have an even blades, they don't give very good stability. And it works, you have wind, which is spins the turbine with a rotor which is connected to a generator, and a generator at the end of the day gives electricity. And this generator can be either direct current generator, or it can be alternating generator. And it will be very simple to shift from one type of current to the other type, which will be the subject of what we'll do today. We pointed out that we have two types of this wind energy system. We have horizontal axis wind turbine, which which blades rotate around horizontal axis parallel to the ground, and are most commonly used for large scale power generation systems. And we have the second one, which are vertical axis wind turbine, which blades rotate around a vertical axis perpendicular to the ground. And they are more suitable for urban, off-grid, and low wind speed environments. And after that, we covered a number of issues related to how can someone estimate the potential of this wind energy. And we realized that this energy can be estimated by the equation half times A, which is the area, the airflow area, rho as a density times the density of air, times V, the wind speed power 3, and times T. So at the end of the day, we realize that we have two factors which can be worked on to change energy of a wind system. Either you work on the airflow area, or you work on the speed. But for the airflow area, we have a limitation, because if you have too long blades, they can be unstable. But you can work easily on the speed by increasing the height of the turbine. And this can be done using tall pole. We pointed out that when you make the graph of power out of wind speed, the power increases as the wind speed increases, and it reaches a saturation. It means at a given speed, even if you increase the speed, you cannot increase the speed. The system is designed to limit the speed by using gears in the system. So What are the main advantages of wind power? The first one, we saw that wind power is cost effective. Wind power can create jobs. It's a clean fuel source. Wind is a domestic source of energy. It is sustainable, and wind turbine can be built on existing farms or on existing ranch. So wind energy applications can be in solar powered generation system, utilities. We can use it. We are going to see how we can use these in different agricultural value chain. And challenges on wind power, we have wind power must be competitive with conventional generation source of energy such as hydropower, and it needs a big chunk of land, which can be a problem in some countries where when you compute the opportunity cost of land, producing energy cannot be the good option. Maybe building is a good option. And the other one, wind wind turbines are set very remote area location from where the energy is used, and making electric lines very expensive at the end of the day. So wind resource development might not be the most profitable use of the land. And people should be able to know where it's possible to do that and where it cannot be benefit to use a land for wind production. So sometimes turbine can cause noise and aesthetic pollution. And finally, wind plants can impact on local wildlife, mainly birds, which can be killed with blades when rotating. So what are challenges of wind power? As I was saying, the challenge wind power has limited, when the speed is limited, the energy produced is also limited. Secondly, we have seen that production of wind speed is a long process. It takes sometimes 4 to 6 months to be able to set up a wind system. So we had another number of challenges, and we concluded from that, and we moved to solar energy. Solar energy. What is about solar energy? We said the solar energy is energy derived from the sun's radiation. It's a renewable and inexhaustible source of energy. So 2 ways of making that use. The first one is using the light, and the second one using the heat. When we use the light of solar, we are talking about photovoltaic systems, and when we are using the heat, we are talking with the thermal solar system, which have their own advantages and disadvantages. So this theory, this technology is well known because it has been set up by physicists for a long time, since the beginning of 19 years and up to date. it has been developed. So we have solar thermal systems, and we have voltaic systems. How do we go for photovoltaic system? The first one, you mount your structure. And this structure can be either the roofing or a structure you mount outside your house, or it can be a building integrated power voltaic system. So when it is integrated, it can be on walls or on windows and so on. So photovoltaic, after doing that, you have to put your solar panel, which are essential part of your system. And after that, the panel, solar having cells, they can produce electricity, and mainly produced using semiconductor, which can be silicon or germanium. Silicon is the most used semiconductor. So after that, we realized that after doing your solar panels, which can be monocrystalline silicon cells with or polycrystalline silicon cells or amorphous silicon cells. And from that, you can convert the direct power which comes from those cells using converters, either in direct current to alternative current, and you can power your system, or you can use direct current to store that energy in batteries, so that the energy can be used when we don't have solar energy. So how can we estimate the energy with the potential energy we can get from a solar photovoltaic system? The relationship is very simple. You have to take the solar irradiation, which is in megawatt per square meters. You multiply it with the area covered by the solar panel. You multiply by the system efficiency, and you multiply finally with the peak sunlight hours, which are given in number of hours per day. So we have factors which can influence solar energy estimation. We have the first one, solar irradiation level. We have the second one, system efficiency. We have the panel or tilt and orientation, because I said the panel should be tilt between 2 and 15 degrees as an angle to allow these panels to be self-clean when there is rain. And you don't have to go beyond that, otherwise the efficiency is going to be very low, and the system will not be very useful. So we finish this part of the course of this solar energy, but the map of African solar radiation map, which has shown that the whole continent, the whole Africa, can be able to provide energy, solar energy, with very good efficiency. So advantages of solar system, we have, it's a clean and no polluting source of energy. It's a renewable energy, and solar cells do not produce any noise, or they are really totally silent. They don't require any fuel to power them. They require very little maintenance. But as an advantage, we have they are long lasting, and it can be a renewable, a reliable source of energy where it's possible to produce it. They have a long lifetime, and that long lifetime is estimated to be around 25 years. There is no need of fuel to power them. As disadvantages, we have solar power cannot be obtained in night time, so the need of big storage. They are very expensive currently, but as the technology is well mastered, we do believe that in the future the price will go down. They have energy has to be stored in batteries, and no air pollution has been noticed. So, and the last one, they need large area of land to produce a big power efficient and big power energy. So that one took us to biomass as the other types of renewable energy. What is biomass energy? Is biomass converted to energy, and what are advantage of biomass energy? Those are mainly the three questions we are trying to answer for each type of energy. So it originated from organic materials that can be replaced. They are relatively quickly replaced in the nature. So we have plants which are made to convert those organic matter in energy or other form of electricity. So after that, we have seen that we can have them from agricultural residues. We can have them from forestry residues and wood waste. We can have them from animal waste. We can have them from municipal solid waste. We can have them in dedicated
Professor, I think you've muted you. Professor,
biomass is a clean energy source. It means it can minimize the possibility of fill up a landfill. It is biomass emit less harmful gases, and it's a renewable source of energy. And as I said, it can be versatile, because for biomass to be sustainable, you should produce more than what you are using. So among these advantages of biomass energy, it's comparatively inefficient to fossil fuels, and the combustion of biomass requires a lot of space. it leads to sometimes to environmental degradation, and it may be harmful to nature mother. So we have to pay attention to when we are cutting biomass to make sure that we are cutting less than what we are producing. And we end up this part of renewable energy by covering geothermal source of energy. So geothermal source of energy, which is coming from the heat, which is stored beneath the Earth's surface. And we saw that how we can use it, or how it the energy is produced, and finally how does energy work. So we said we have electricity generation as a way of use of geothermal energy, and we have also direct heating. So either you produce electricity or you use water directly for heating. So you can use geothermal heat pumps to do that, or you can also use agriculture, hot water in agriculture and aquaculture. So we have mainly the big problem when you are you want to use geothermal energy. It's about exploration and drilling. Exploration and drilling is really very costly, and sometimes you can put a big amount of money in and you have nothing. We have the experience of Rwanda, which has used $2 million just for drilling, but they drilled on the wrong place and the money got lost. So we have seen that we can convert also that energy, and three ways of converting that energy. Either we use a dry steam system, we can also use a flash plant system, or a binary plant. Those are three ways of converting that energy in electricity. So we have seen some elements which can affect the energy, geothermal energy, mainly the reservoir temperature, the reservoir volume, the porosity of the rock, and those elements, they intervene when you are assessing, you are estimating the geothermal energy. And we complete this part by giving some advantages and disadvantages of geothermal energy. And among disadvantages of geothermal, we see that sometimes it can emit some hydrogen sulfide, which can be harmful for the environment. And among advantages, we see that it's a very cheap source of energy compared to fossil fuel. And we have seen that it is an inexpensive source of energy, sustainable, and environmentally friendly type of energy. Geothermal is not without the big disadvantage, which is mainly we can see a source after some time dries. And if the source dries, it means that you can no longer produce energy from geothermal. So these are what we have seen for this type of energy. But what are the major basic characteristics of this of this renewable energy. So I think I've finished with the recall, and we start with now the base functional characteristic of renewable energy. The first one is dependence on natural resources. We have seen, for instance, to produce energy from solar, from using solar power and so on, or in the wind, we need wind, we need solar, we need water for hydropower, and we need hot water heat from geothermal. That's a first characteristic of renewable source of energy. The second characteristic is conversion technology and efficiency. We need, at the end of the day, to convert those primary sources of energy to the carrier, which is electricity. And the technology is around, well mastered, but the big problem, sometimes the efficiency is low. And we have seen sometimes it's very difficult to go beyond 18% of efficiency when we are using solar cells. Third, characteristics of these renewable energy sources is environmental effect. So when you use this renewable energy, we have realized that they don't emit. So we have low greenhouse gas emissions during operation, and we reduce reliance on non-renewable resources, such as fossil fuels, which emit a big amount of greenhouse gases and badly impact climate change. 5 characteristic, we have more modularity and scalability. So these have advantages. You can mount them using different modules, so which you can increase as the demand also increase. So modular designs allows to increase the system as the demand increases. And maybe we have also finally economic viability. They operate with low running costs, and they don't need fuel to power them, and they support the problem. Often they are supported by incentives like subsidies or tax reduction. So that is the major characteristics of this renewable energy system, and it takes us to module 2. The module 2, which is about clean energy options for agriculture value chains. And these value chains was, we pointed outside, they take into account the input, the production, the local transport, the storage and handling system, the value addition processing system, and at the end of the day, we have also to consider end users. So let's say, for instance, when we have a solar system can be used to power irrigation systems. They work very well. You have a solar pump and they use solar to power them and to do some irrigation. Solar can be used in drying units. So when you have your agricultural product, you need to preserve them, or you need to process them, you can process them or preserving them by drying them. And the solar can be used. And even also geothermal can be also used in processing as well as in preserving when it comes to drying. Solar can be used for cooling unit. So when you want to optimal maintaining your product using low level of temperature, you can use solar, and you store your seed, your fertilizers, and as a product. Solar can be used in precision agriculture. So when you use solar power in Internet of Things to power some devices which can assist in optimizing input use. And among input use, you can see fertilizers, we can see water, we can see pesticide and other input element. And all that is done using Internet of Things devices. We can use energy in warehouses, and solar can be used as energy efficient warehouses technology. And this can be easily done. So we can also use geothermal energy, for instance, for greenhouse powered by geothermal. You see, when you want to have heat in greenhouses, or you can also regulate that heat using devices, we can make use of geothermal energy. As I pointed out before, geothermal can be also used for drying and processing product. We can use wind energy as well when it comes to produce energy, and to have a wind turbine which can power production plant for seeds, for pesticide and other agricultural output. So we can use wind energy in many ways, and other types of energy when it comes to irrigation, when it comes to domestic power supply, when it comes to power supply of integrated fish ponds and crop production. We can use renewable energy for greenhouse heating and cooling. We can use renewable energy in crop drying and preservation. We can use this energy in agriculture for when it comes to precision agriculture, as I said, to optimize inputs like water, fertilizers, and pesticide. And we can use renewable energy for post-harvest and food processing. So we have a number of ways and application for this renewable energy. For instance, cold storage, when you want to do some cold storage, when you want to control moisture, when you want for value added processing system, when it comes to milling, when it comes to storage and warehouse. So you can even use also geothermal for soil sterilization, or using hot water coming from geothermal system you can use it also for fertilizer production. So we can use it in a number of things, and mainly when you want to produce electricity on farm for generation of electricity, you can use those systems. And you can use the system for all heating applications. So these are some of use of these renewable energy in agricultural value chain. But also, I said you can use also this energy in transportation by producing biofuels, and biofuels like ethanol, like biodiesel, biodiesel, and other advanced biofuels can be produced to power transportation system. We use it also for industrial applications, and industrial application for heat processing, as well as when it comes to cogeneration. So, as we can use also in biogas, which we'll cover later on. So, having said that, we have seen that many this renewable energy can be used for a number of applications. For instance, biomass as source of energy can be used for carbon sequestration and for improving soil health. But what are challenges in the use of renewable source of energy? The first one, as I said, and this is the rationale for this course, limited knowledge. As we said, agriculture is mostly done by rural people. And these people, sometimes they lack knowledge in this, how to engineer or how to harness this type of renewable energy. That's the first limitation of use of this type of energy, limited knowledge. The second one is energy storage challenges. We have seen, for instance, when it is about solar energy, it can be only produced during daytime because it depends on solar. As wind also, it depends on wind, which is very good when we are now at night time. So wind energy can, I said, solar and wind energy, they have the problem, they need storage because they are not permanent all the time. And storage are sometimes costly because we have to buy a number of batteries. Limitation, third one, we have infrastructure limitation. And this applies most in a number of African countries, because sometimes we need to be connected to the national grid or to do some interconnection to be able to use renewable energy in producing decentralized areas. So coming to challenges, we have environmental concerns. They can pollute the environment, aesthetic pollution, and they can sometimes also kill birds when blades are rotating. For hydropower, we have seen that they have a problem with ecosystem disruption, and sometimes they present a problem of displacement of communities when it comes to building big dams. Because when you build the big dams, not only they have a big impact on the environment, but also on population. They need to displace communities. For geothermal, they have a risk of land subsidence. And when it's not well done, when you are drilling, and if you do it wrongly, it can even trigger a eruption, a volcanic eruption when we drill in a magmatic reservoir. So these are things we can retain, which things on which teacher can put more emphasis when is giving this course to student as well as to the student. And it takes us to module 3, which is about conversion devices. And I'm going to give the floor to Professor Majaliwa to proceed. Prof. Majaliwa, over to you.
Okay, thank you very much, Professor Kacho. So this is module 3 on conversion devices. Basically, a conversion device, the way it is defined is converting from a given type of energy to another, moving from one to another. So all those devices are basically conversion devices. Certainly, there are also those other devices which move from the direct current to alternating current, or from alternating current to direct current. So those are the different devices we are going to discuss in this section. Yeah, so if we look at solar, we have basically two types, though here I've presented them as three. So you have the thermal collectors. Those thermal collectors assist you to accumulate heat from the sun. But also you have the photovoltaic, which assists you to transform the heat into electricity. So for the collectors, we have a number of them. So we have basically different systems which have been used across time, and their major characteristics is basically the paint on top of them. And most of them are painted in black. And we know why they are painted in black, because black means more of the radiations are actually moving through the system. So you have the unglazed collectors, you have the flat plates, you have the evacuated tubes, but you have the parabolic troughs, which have been used over time. These are some of the examples I've said, but we also have the concentrated collectors. Basically, these take different shapes, but in most cases, they are also parabolic, and with energy concentrated at a focal point. So this is how it works. Again, you see that most of the radiations moving on the receiver are actually converging on this particular focal point, and that's where the objects which need the heat is actually placed. Then you have the pipes with thermal fluids. And again, as I said, the major characteristics here is the paint, and a number of tubings is going through the system, and because of the paint, they actually absorb most of the heat. So you also have these heliostats. The heliostats also work almost similar to the parabolic reflectors to allow a concentration of heat at a particular spot. So sometimes these thermal solar collectors coupled with a number of systems. So you can have tanks, and these tanks can also be equipped with heaters. In case the collectors are not working, then the heaters will actually play the role of providing the heat for the water. So this is another type of design where you have a series of collectors, and then you have a controller to control the temperature and the flow of the fluid into the storage tank. And again, the storage tank is also equipped with a heater in case the collectors are not working. And you see in this case, you have a pump for evacuating water from the tank if it has cooled, and it is channeled again into the collector. So in some cases, and basically these systems, there are three major systems as we discussed before. So there are those ones which are grid tied, there are those ones which are off grid, and those which are hybrid. So in terms of hydropower, we have different systems of devices which assist to transform the kinetic energy and the difference in potential energy into electricity. And then those are the ones, the Pelton, the Francis, the Kaplan, the cross-flow and propeller turbine and bulb turbines, which can be used for this purpose. So if you look at the Francis, for example, the shape of the vein and their distribution in the system assist in actually accumulating water and creating more kinetic energy, and therefore more electricity. So if we look at the Kaplan, for example, we actually see that the shape of the blade is a bit different from that one of the Francis. And this assists in terms of guiding the water to generate the required electricity. If you look at the Kaplan, it's a bit different from the Francis, and it's a bit different from the Francis because basically, basically because if you look at my figure here on the left, the way water moves through the systems from different parts to go into the propeller, which is likely to rotate and create the energy. The arrangement is basically different, and the position of the shaft is very, very different. So the Pelton, a bit like the Francis, but here again you see that the bucket, the system has buckets which allow to get water and move and make the rotation required to generate power. So if you look at the propeller, not very close to, but very, very, very close to the Kaplan system. If we look at the gross flow turbines, again here, water moves into the system, and you have the curved blades which actually rotates and allow the system to generate some kinetic energy which will be transformed into electricity later by another system. So this table is very important if someone is looking at these conversion systems and compare them in terms of their characteristics. Now, if we are looking at wind, as we discussed before, so you have different systems. Again, as we said, they are horizontal and then the vertical type. But the most important thing here is that you have also rotors. I think Prof. Karume talked about the blades and the number of blades which are required. We saw that you can have 3 of them, you can have 2, you can have 1. So you have your blade, you have your rotor, but there is a gearbox which assists the system to define the speed limit, but also we have a controller of that speed limit. This is how, as I said, it is. So we basically have the rotor and the blades, and then you have the shaft and your gearbox, but you also have a generator, which assists now to move from the kinetic energy into electricity. So this is the image of what I presented before, and we see a big difference again here between those one with vertical axis and those one with horizontal axis. For horizontal axis, the gearbox and the generator on top of the tower, and for the vertical one, the gearbox and the generator are actually at the base of the tower. So you can have different systems here, or different types of vertical axis. You see the different shapes, and those different shapes have, each of them has its own advantages in terms of stability of the system, but also the amount of energy generated. So this is just a summary to show that once power is generated, of course, it can be loaded on the grid, or it can be stored. So this is the same message here. Now, what happened to biomass? So there are different also technologies in the market, and we want to just talk about a few of them. So basically, we as I said, we can actually have this technology for traditional domestic use. It can be for industrial use, but also it can be for technology development. So among these technologies, especially at domestic level, we have the traditional, the cooking stove, which assists to convert energy for domestic use. So there are a number of these in most of our rural areas, even in the urban areas. So we have the 3 stones, for example, and then we could have a saving stone, a saving cooking stove. The difference here is basically in terms of efficiency, but also in terms of comfort. The other one, the 3 stone, is basically open, and the person who is cooking is actually exposed, or she is exposed to, because generally we know the people who cook. So she is exposed to the smoke from the device. But if you go into a saving one, basically the amount of smoke is reduced, but also the efficiency in terms of energy is also improved. So you also have a number of them of improved one with clay, and then you have the metallic one, but you also have very improved, very nice and improved system on the market with very nice efficiency. So basically, for most of them, the thermal efficiency is computed that way. So we need to see the energy, the actual energy used, and then the fire which has been powered. That ratio is giving us the thermal efficiency. So this table is important because it shows how the different stoves actually compare, for example, even to electric induction stove. And we actually see the three stones, they vary between actually 10 to 15, but sometimes it can go up to 5. But the improved one vary between 20 to 40. I think the Lorena could actually go up to 40, and then we have the rocket stove, which goes up to 50. So then you have the other stove for gasification or liquefaction of petroleum gases, which goes to higher efficiency. So this is one of the improved stove, which is called a Philips draft cook stove, with almost 38% efficiency, but where emission or particle matters and carbon monoxide have actually been reduced. The other device is basically the biomass boilers. So the biomass boilers works in following the concept of bio refinery, where you have the biomass and then their platform for sugar and the syngas, but also you have the two, the residual and the clean gases combining to create heat and power. And the syngas and sugar platform actually contribute to fuel and chemical and other materials. The second one is the biodiesel and the e-diesel. This biodiesel is actually made from the animal fat or vegetation oil. It can also come from rapeseeds like the soybeans. It can also come from jatropha. And the e-diesel assists you to basically get a blend of ethanol with diesel. And in this blend, you have a ratio of 7.7 or 15%, and sometimes it goes up to 5%. Now, for the biodigester, this is basically where the biomass is actually converted into organic waste, but also into biogas, and especially methane. And methane is actually recovered and used for other purposes. Basically, you have an influx of this organic waste into a system allowed to mix and covered, which start generating through this anaerobic digestions some gases which can actually be recovered. And then the effluent can actually be used for other things. So the gasifier uses almost the same principle as the biomass digester. The difference here, if you can look at the lower part, is that you have two chambers which allow you to collect your gas in a different way. So there are different type of gasifiers, and a person teaching this should be able to present the updraft and downdraft, the twin fire, and cross-draft gas producers. So after that, I think the key is basically the direct to alternating and vice versa. And let Prof. Karume discuss the direct alternating and vice versa conversion.
Thank you, Professor Majaliwa. As we have seen, in geothermal, we have a generator. In wind energy, wind system, we have a generator. In a hydropower system, we have a generator, and biomass, when it's converted to electricity, we have a generator. And these generators, they can be either producing alternating current or direct current. So there is need to come from one type or to the other type of current according and depending on devices you are using. So let's first consider direct to alternating current. First of all, as we said, we convert primary energy to the secondary energy, which carrier is electricity. So what is electricity? Electricity flows when the electricity, let's go, okay. Electricity is the move of electrons in a system. So when we have direct to electricity flows in two ways, either in an alternating current or in a direct current. Electricity or current is a movement of electrons through a conductor. So the difference between I'm going to abbreviate alternating current to AC and direct current to DC. So what's the difference between AC and DC? The difference lies in the direction of flow of electrons. So in DC, the electrons flow steadily, let's say in a single direction. And when it comes to AC, electricity keeps switching in two directions. So sometimes it goes forward and then goes backward. That is why we call it alternating current, because it goes forward and backward. But direct current, it goes just in one direction. So alternating current is the best way of transporting electricity, because the technology is cheap and it doesn't require a lot of things. In the story of on Africa continent, I think there is only one line which has been made, which has been done using, which has been used for carrying DC current, and that line is in DR Congo. It is from Inga to Shaba. and it's costly 10 times what can cost the same line transporting AC. So that's why people, when we realize that when they are producing in electricity, generally the electricity is producing in DC form, and we have to transform it in AC to be able to transport that energy where it can be used. So we have a table which is giving the difference advantages of these different current, DC and AC. So the one teaching this course can just have that and give an announcement or assignment to student to just read. It's easy to read and to know. Conversion device, which we are talking about, they are mainly transforming waves. As we were saying, this conversion device, we call them rectifier, is an electrical device that converts alternating current within a periodically reverse direction to direct current which is going in one direction. So we can do that in three ways. The first way is a half wave rectifier. So when you see a AC current, you can get it as a sinusoid, and you have a half part on a up part of the axis, and another part in the low part of it. And when you are talking about half wave, it means you see just one part, either the one being up the axis or one being down the axis. The second way is a full wave rectifier. This one takes into account the two parts of the signal, which is a sinusoidal signal. And finally, we have a bridge rectifier. The bridge rectifiers we are going to see is using mainly diodes, which are electronic components. So let's talk about half-wave rectifier. A half-wave rectifier
Did we lose? I think we have lost Prof. Karumi. Let's give him some 1 or 2 minutes. Otherwise, I will take over in case there are issues.
Do you get me?
No, we actually lost you, Prof. Go ahead.
I can go ahead. At which level have you lost me?
No, you're actually on halfway rectifier.
Okay. So I was saying half-wave rectifier, in halfway rectification, either the positive or negative half of the EC wave is passed and the other one is blocked. Since only one half is passed on the input wave point, at the end of the day, you have a very inefficient use of power transfer. And to get rid of that, to get out of this, we now go to the full wave rectifier, which generally and basically it passes the two parts of the waves. So the upper part and the down part of the wave. And at the end of the day, you have a very good efficiency. So the full wave rectification convert both polarities, negative as well as the positive polarity on the input waveform to direct current. So, but now the issue is when you pass the two parts of the wave, you don't have a good direct current, because a good direct current should be symbolized by a line, a horizontal line. But for this one, you have just two waves coming closer one to the other one. To make it very good, you have to use additional material, and that's why we go to the bridge rectifier. The bridge rectifier is a bridge which is made out of diodes, and generally for diodes which are presented as a bridge. And as they are four, they are like a bridge, they can correct the signal. So you have this bridge. After getting a AC current, you go through a transformer, and after the transformer, to reduce the voltage, you can now input in the bridge, and the output can be a DC power. The principle of this doing is mainly the transformer. So you cannot do conversion without talking about transformer. So let me see how many types of transformer we have. Do we have? The first one is a auto transformer. So the second one is a three-phase transformer. So for the three-phase transformer, you have the three-phase coming in, and you don't need the neutral, because neutral may come or may not. You can get the neutral on the land, on the soil, because that is at zero potential. After the three-phase transformer, we have a constant voltage transformer. We have a voltage transformer, which is mainly used to transform voltage. We have a current transformer for transforming current. We have a safety transformer, and finally, we have a single-phase transformer. Those are the different types of transformers we can find in our normal lives. So as I was talking about transformer, we can see how it can be presented. We have here three transformers with two circuits, which are electrically independent, but they are linked magnetically. So the first part, which we call primary circuit, it's where you input the voltage. And the second part is the secondary part of the transformer. It's where you get your output voltage. So as I was saying, this transformer can be a voltage transformer, a current transformer, so on and so on. So this also is another figure showing a transformer. And this figure, you can notice that you have a part which is used for cooling the transformer. And this part is useful for a transformer, otherwise the transformer can heat up and at the end of the day break down. So we can have this conversion device based on functionality. So when you want to group these transformers, you can group them based on functionality. And based on functionality, we have the first type of transformer is called the step-up transformer, which basically, as I said, the input is lower than the output. So if you come with a low voltage on input, you get a high voltage on output. That's how we call it a step-up. And in opposition, we can have also a step-down transformer. And you are going to realize most of the time, this transformer, they are used both in the circuit. Because look, you generate energy somewhere using hydropower or using wind power, wind system. You produce that energy, let's say, using obtaining 220 voltage, but you have to transport it. And you cannot transport low voltage because losses are going to be high. And at the end of the line, you will get a very, very low voltage. So what do we have to do? We first put that low voltage, the 220 volts or the 380 volts, to a setup transformer to take up the voltage, to take it on the line. And when you arrive at a point where the energy is going to be used, now you can reduce using a setup, a step-down transformer, because most of the time you transport electricity using 15 kilovolt, 220 kilovolt, 330 kilovolt. It's generally a high voltage. So that's why we use at the beginning of the network a step-up transformer, and at the end we use a step-down transformer to get voltage which devices can support. So we can also have a isolation transformer. A isolation transformer is mainly used to isolate the source of power and the use of power. For instance, when you are installing your house, normally you take the phase and you distribute the phase, and
okay.
I was saying you can take the neutral or you take it on the ground. So when the ground is on soil, it means whenever you touch to the phase, you can be subject to electricity. So to avoid that, for instance, when someone is bathing, to keep him safe, people do use a isolation transformer, because at that point, the ground is no longer on the neutral is no longer on the ground, but the ground you get it directly on the transformer. So it is used mainly for safety reasons. When people are working in a humid environment, when the environment is wet, you use a isolation transformer. So in addition to that, we can have a auto transformer. Is a single winding transformer that serve as both primary and secondary. So instead of having two winding, we have just one winding. So when the output is taken somewhere at the middle of the winding, you have a step-down transformer. But when the primary is small and the winding is too long and the output at the end, that one is a step up transformer. So based on construction, we have a number of transformer. We have the first type, a core type transformer. The second type is a shell type transformer. And the third one is a berry type transformer. That is based on construction. Based on cooling method, because as we know, is a Joule principle. When a conductor is, when current is passes a conductor, it ends up by producing heat. And so if you have a winding, it means a number of wires coming together. It means at the end of the day, you are concentrating heat. And that heat can break down a transformer. So there is need to cool up a transformer when it's working. So based on a cooling method, we can have three types of transformers. The first one is an oil-cooled transformer. So the material used to cool the transformer is oil. And people use oil which it cannot burn fast, easily. Oil with a high level of burning. We can also use an air-cooled transformer. So the cooling material is air, and finally, we can use water-cooled transformer. Those are three types of transformer we can have based on cooling method. So we can have also high voltage transformer, which can be used, and low voltage transformers. Okay. Based on phase, we can have two types of transformers. One is a single phase transformer, which is mainly used in a household and small appliances. And we have a three-phase transformers, which are used in industrial and high power application. So these are the type of transformer we can have based on the number of phases which they power them. And we have at the end of all this, the special transformers, which can be variable transformers. We have pole-mounted transformer, which are mainly made outside environment, and they are fixed on poles in different environments. And we have substitution transformers. Those are different types of transformers which are mainly used for step up or step down electricity, voltage electricity. And transformers, they are mainly used with alternative current. You don't transform direct current before transforming in alternating current. This is a very simple physical principle. So when you have a direct current, before stepping it up or stepping it down, you have first to transform it in AC current, and now it will be possible to make it. So, Prof. Majaliwa, I suggest Before we move to the other part, which is about designing and so on, and maintenance of the system, we give a chance to participants to ask questions.
Yeah, thank you, Prof. I think we are remaining with 10 minutes. So we can give the 10 minutes to the participant to ask questions. Then the design will come tomorrow. That's my suggestion. So let's get, Jolene, can you assist us to collect the questions?
Yes, Prof. I would request the participants, if they have questions, they could raise up their hands and we can call upon them, or put their questions in the chat. Professor, there are some people who are asking whether they'll be able to get the PDF of this training material.
Yeah, that's obvious. By the end of this training, they will get the PowerPoint. We will finalize the document, the text, the Word document, and share also with them. We just need to format it.
Thank you. And may I remind all the participants to kindly register on the provided link in the chat. Make sure you register in the link provided in the chat. Thank you. I am not seeing any questions so far, so probably we can maybe summarize for the day. And yeah, I think so.
Yeah, I think we just need to say thank you for all the participants. I think the numbers have been floating between 55 and 60. So that's a very good attendance. So thank you very much to all of you. If you manage to get another question as you go back home, kindly bring it tomorrow for discussion. Otherwise, let's close the meeting, or let's suspend the meeting for today, and we'll meet tomorrow.
Yes, thank you so much, Professor. Thank you, everyone, for being part of this training. Let's meet again tomorrow at the same time for another episode of this training. Thank you very much, and bye.
Okay, bye.